Hi, in this lesson we're going to do the first few steps in looking at the binomial expansion. So this is basically a method where we can expand brackets with greater and greater powers. So traditionally, using like basic GCSE maths, expanding this is pretty straightforward. This takes a bit of work, but anything beyond that kind of becomes almost impossible. It's just, there's too many terms to comfortably deal with. So just as a recap, let's start right at the beginning. Let's look at x plus y all squared. Okay. So to do this, typically your wisest first step is remember that squared means times by itself, and you expand it like this. From here you've got a bunch of choices. You've got the grid method, you've got FOIL, and so on and so forth. Either way, whichever method you're doing, the method or the idea behind the method is the same. You need to times every term in this bracket by every term in this bracket. So you've got to do x times x, and you've got to do x times y. Do that now. That gives me x squared plus xy. And then we do the same thing with this y. I've got to times each term over here by this y. So here I've got plus y times x plus y squared. And you simplify this down into x squared plus 2xy plus y squared. So the key idea, however you do it, is you always end up multiplying every term in this bracket by every term in this bracket. I'm going to show you a different way to visualize that, and from there we're going to look at the binomial expansion, which makes the whole thing a lot faster. So I could visualize that in terms of branches of a tree diagram. So, you've done tree diagrams before probably. Going down each branch, you have to multiply. So here x times x is x squared, x times y is xy, y times x is yx, and y times y is y squared. And if we add all these together, we get the same answer as before. Okay, so there's nothing new we've already learned here, but it's a different way of looking at it. And we can kind of see here that why this gets so hard so quickly. If I did the same thing with a third branch, suddenly we've got loads of combinations. Again, the fourth branch is pretty much unmanageable. They're going to be so small and so many of them, you can't really work with it. But here, this we can just about work with. So let's start doing that. I won't finish it, but I can start it. So I'm going to get my powers in order. I'm going to start with the biggest power of x, which is going to be this branch here, which gives me my x cubed term. The next term I want, I'm going to try and see how I can get an x squared y. So x squared y means x times x and then a y. So two x's and a y. And it turns out there are three ways of doing this. We've got one here, I have another one here, and another one here. So when you do expand it out, you'll say you've got three lots of x squared y. And you keep doing this for the other two terms, so you'd also have some xy squareds and some y cubes as well. Now hopefully this reminded you that we had the same kind of problem, the same kind of difficulties when we looked at tree diagrams, which led us towards doing binomial distributions, which made things a lot quicker. Here we're doing the exact same thing. So let's look at these three terms, and let's not group terms together. So we're going to pretend indices don't exist right now. So here xxy, I'm going to keep as xxy. Here I've got xyx, and here there is yxx. All these terms, when you simplify them, become x squared y. But hopefully this just reminds you of the permutations and combinations problem. If you have two x's and one y, there are three different ways you can write them down. And in fact, we can get this number, as in the 3x squared y, by doing the total number of letters, which is 3, divided by each group. So I have two x's and I have one y. Okay, that will give you 3, which is why it is 3x squared y. There are three lots of this term. And let's not forget, you can also do that in a more shorthand fashion by doing 3 choose 1 or 3 choose 2 on your calculator. And that will also give you the same number back. And we're going to use that now. We're going to use that to work out a much harder problem. So we're going to look at x plus y to the power of 5. So here remember that from each bracket, and again there are 5 brackets, we're either going to get an x or a y. And we're going to look at all our possible combinations and how many of those combinations we have. So the first combination is if from every single bracket I get an x. Okay, and that can only occur once. So therefore I'm going to have 1, I'll put a 1 there, x to the power of 5. Next I'll go down in powers of x, so I could also have 4 x's and a y. And this can occur multiple times. again, I could also have xy, xxx. And that's the same term. That'll be another x to the 4y. And we can work out how many of these they're going to be. I'm going to have 5 choose 1 lots of these. So overall, this is going to be 5x to the 4y. And just to explain that, that is because if I do 5 choose to the 1, it gives me 5. And I can keep going. My next term, I'm going to have x cubed y squared. So I'm going to have 3 x's and 2 y's. And then we think, how many ways can I organise those 5 letters? Well, that is going to be 5 choose 2 or 5 choose 3. So we go to our calculator again. 5 choose 2, and that gives us 10. So that means there's going to be 10 lots of x cubed y squareds. There were 10 different ways I could write 3 x's and 2 y's when I expanded out these brackets. And we keep going. My next term is 2 x's and 3 y's. So for that, we can have 5 choose 2 or 5 choose 3. And that will also be 10. So you'd have 10x squared y cubed. Then we get into the end. So if we have 1x and 4 y's, that is now 5 choose 4 or 5 choose 1. Either way, that is 5x. So it's 5xy to the 4. And then lastly, I could also have all 5 of my terms being y's. Okay, and to be complete, this is technically 5 choose 5 or 5 choose 0. Either way, that's 1. So there's only one y to the 5 term. And that's it. And now we've expanded out this long, complicated mess. So again, for your final answer, you'd group all these terms together, and you would see x to the 5 plus 5 of this plus 10 of this, and so on and so forth. And that's the gist of what we're going over in today's lesson. So let's change it slightly. I'm going to have a few more twists to this. So we just expanded this, we grouped it together, and it gave us this form here. We could also expand x plus 3 to the power of 5. So if I compare this to this, the only difference is I have let y equal 3. I've replaced all my y's with 3's. So to work it out, you basically just copy this down. But every time we see a y, we know it means a times by 3. I'm going to write times by 3 just so it's obvious it's not sort of 53 or something. So again, I'm just copying this down, and any time I see a y, I'm basically writing 3. And now if you wanted to expand this out properly, you would have to times all those terms together. So what I mean is, this one doesn't change, it's still x to the 5. Here, you want to times all your numbers together. You want the numbers at the front. So you've basically got 5 times 3. So this would be 15x to the 4. Next, you would have 10 times 3 squared. 3 squared is 9, so it would be 90x cubed. Plus, we've now got 10 times 3 cubed. 3 cubed is 27. So 27 times 10 gives me 270. So I have 270x squareds. I've now got 5 times 3 to the 4. 3 to the power of 4 is 81. Timesing that by 5 is going to be 405. So I'll have plus 405x. And then plus 3 to the 5. 3 to the power of 5 is 243. Okay, so we can use it to work out slightly harder ones if we just change y. Okay, again, all I've done here is I copy this down and I placed every y with a number 3 and then worked out all the terms and times them together. So there's nothing groundbreaking there. Okay? Again, you've simplified terms together. You can basically times all your numbers together and then keep the letters separately. That's all I've done here. I've done nothing overly complicated. Let's quickly start a student problem so you've got the idea of how it's going on. So if I want a plus b to the power of 6, I start it the exact same way. It makes sense with these questions. You always do it in a systematic order. So I'm going to start with 6a's, then 5a's, then 4a's, and then 3a's, and so on and so forth. So I've got 6a's. That is basically 6 choose 0, so it'll give, which equals 1, sorry. So I would have 1a to the 6. I would then have 5a's and a b. So a's and b's here. That is now 6 choose 1. That equals 6. So I now have 6a to the 5. I've then got 4a's and 2b's. That you have 6 choose 2 options, how you can arrange those letters. 6 choose 2 is 15. So you'd then have 15a to the 4. And you would keep going. You just keep following that pattern. Each time these powers change, I've messed up slightly here because I forgot my b's. So I had 6a to the 5b and 15a to the 4b squared. And you would keep doing it. You'd then have a cubed b cubed, a squared b to the 4, and so on and so forth until you get b to the 6. b6 is always your last term. And again, from here, I could work out something like a plus 5 to the power 6. Let me start for the first 3 terms. So my first 3 terms were here. If I'm working a plus 5 to the power 6 rather than a plus b to the power 6, that is the exact same question, except now I've replaced my b's with 5. So a to the 6, that would change. That won't change at all because that's only got a's in and no b's. I've then got 6a to the 5b. So that is going to be 6a to the 5 times 5, because b is now 5. We do 6 times 5, which gives us 30, so it is 30a to the 5. We can do the same thing here. We've now got 15a to the 4, and rather than times b squared, we've now got times 5 squared. So we do 15 times 25, which I'm afraid I can't do in my head. That is 375. So we then have 375a to the 4. And you would keep going. You keep going all the way until you've got just a number at the end. Because each time your power is getting 1 lower. So it'll be a6, a5, a4, a3, a2, a1, and then a0, which is just a number. And that's pretty much it. So again, most of this maths here follows on really nicely from the stuff we did probabilities and binomial distributions, except there's no probabilities to it. We just have letters at the end. So it's almost like one less step. However, you do that step multiple times because we need each separate power. That is it. There are some questions here for you to try. Chuck that in a PDF and chuck it in the description. And I hope that made sense, and good luck.